So, good afternoon, everyone. It's a pleasure for me to introduce our next guest speaker, David Morgan, who will be showcasing the collaborative workflows and tools Sasaki have been developed. So, I'll hand off to you now, David.
Cool. Thanks very much, Jed. Yeah, we're not brothers, by the way, but we're
No
Unity
relation.
brothers. Yeah. Awesome. Thanks very much, Jed. Oh, hey, Kitty. Um, I'm gonna just prep this because she might bother me a lot. Um, yeah, hold on 1 second. Come on, Kitty. You gonna hang out with us today? You're the little Speckle cat. Oh no, she's hungry. Okay. See you later, kitty cakes. All right. Professionalism at its max. Okay, so hi everyone, my name is David Morgan. I am a VR specialist over here at Sasaki in Boston, Massachusetts. I'm currently actually living in Mexico at the moment, so we get some nice little remote collaboration happening. So I am going to share my screen and do a little presentation on some of the stuff we've been doing with Speckle. Kitty's back, so hopefully she doesn't bother me too much. Okay. So move this over here. I'm gonna try to keep the chat open. Cool. All right. Are we good? We seeing a screen? Should I pin anything? I will. The dead silence is a raging yes in my mind. Okay. All right. All looking good. Perfect. Cool. Let me hide that. Sweet. Okay. Well, hello everyone. Nice. Thank you very much for joining. So today we're going to be talking a little bit about some of the work we've been doing with Speckle and a bit about our background and why we kind of jumped into things with Speckle and how we want to leverage it with some of the tools we've been working on. So we'll talk a little bit about the firm that I work at, some of the approaches we have with Speckle, and a couple of examples and things like that. So cool. And of course, what presentation's not complete without me talking about myself. So my background is in architecture and fabrication. I graduated with a bachelor's of architecture, but then I kind of made the switch over to VR and programming, kind of like most people here. But when I was studying architecture, I had this real keen interest towards combining things that were physically built with how they could be digitally fabricated. I've always kind of grew up making things, and when I've kind of got introduced to the CNC and laser cutter, I got obsessed with it. And so this was a little shot of a workshop that I helped run that helped teach students how to fabricate a spoon. And there was kind of this challenge of having to make a spoon both within the CNC and in the wood shop. So there's this nice relationship between both the physically made object and the digitally made object. So that's what I kind of find interesting, and it's kind of the reason I really like Speckle at the moment. So a couple of the other things that once I kind of joined the teams over at Sasaki, I got a little bit more focused in VR and all things immersive. I really kind of found that love for how we could figure out a digital craft. So this is an example of a tool that we put together where it was just a little application that took a bunch of LiDAR data and did an AR app that kind of mapped and then mapped all these different tiles onto a little frame, and you could kind of navigate around. And it's nice because you could actually it kind of remind you of one of those tools that you smash up against your face, and all the pins kind of show what your face looks like. And so we like this idea of how do you kind of relate again something that's virtual, digital, and have that relationship kind of tied to a model. There's a little bit more to that, but just to kind of show some preference. And then another project that I've kind of been working on, since I started was, figuring out how VR can actually impact our design workflow. This was a kind of a prototype that we made early on when I started, was in Unity, that kind of took on the idea of how do you build a digital modeling tool that helps you kind of understand the space you're making and helps you kind of iterate and think in there. A lot of our tools deal with how design thinking happens. So this concept was really just bringing in this idea of stacking and doing the typical things that you might do within the design, like a architecture studio, but having that kind of relate in real time. So this is kind of showing program stacking, where you can bring in objects and get real-time data feedback and be able to have some physics behind it. And then we built out a set of different tools that allow you to kind of do different actions for like building architectural elements, and then we use kind of user input to actually like push in and allow you to create like a set of stairs or something like that. And then, you know, after 7 years architecture, this is probably the best thing I've ever made in built space. But I don't know, actually my thesis wasn't too bad. It was just a circle. But you know, what was nice too is like something that we found really attractive about VR was the idea that you can kind of jump in and see something for one-to-one scale. So, and that's something that we kind of stand true to with why we find VR is like such a beneficial tool to the design field. And why we think that it's actually going to help influence how designers think is because you can kind of see scale, you can see proportion and composition of things, whereas like we never really had that before. So, you know, that's like a little bit of my background, kind of jumping in here, some of the tools we made, but we're not talking about VR today, actually. We're just kind of talking about Speckle and some of the work we're doing with that. So over at Sasaki, we're a multidisciplinary firm. And so that means, you know, we have all different types of crazy designers that we work with. And so we have, you know, ranges from urban design and planning to architecture and interior to landscape. So we kind of have like a set of everyone in our firm. And what makes that a unique thing is that everyone has a different way of working and creating. So that's really nice, and you know, it's really kind of beautiful to see the work that they put together and the processes they go through. But I actually work on a specific team called Strategies. That is a group of specialists. We call it, I don't know, we've been labeled misfits. I don't know, you can, whatever. It's probably most of the same people in this whole conference. But you know, this group is really, you know, a set of specialists that work on investigating how the design workflow actually can be improved. You know, be strategic, hence the name. And so, you know, we kind of go through a series of different tools that help us think about how design comes together. It's not about doing analysis of how the design's working, but thinking about how design thinking happens. So it's like thinking about thinking, right? But it's really to kind of help motivate iterating, like thought, like collaboration, and just showcasing what that like information is. So these are some of the earlier tools that you know, before my time at Strategies, that people were like, teams were working on to help kind of visualize spatial planning and helping relate that information back into, you know, three-dimensional drawings, or, you know, just like kind of tying back things that were typically just be numbers, but having it have a relationship to a visual identity. And some of the tools too aren't just about modifying the visualization. It's actually about how do you tie information that we would gather from a client and bring that back into our design work. So, you know, these are different tools that are kind of showing some data we've scraped and how it kind of maps all together, and then kind of showing all the intricacies of how that's all web. And then we've also, like the last tool that I'll kind of show here, I don't know, let's see, let's skip ahead a little bit. This is called CoMap, and this was kind of one of the first tools that we really pushed out to make it a platform that we could deploy for different universities, and they could use this as a way to filter out different forms that students would fill out to say like, how was their experience at the campus so far. And we use that to help us understand our spatial analysis of how things were performing at the urban design level. So, you know, a lot of different tools, a lot of different ways of like illustrating the design intention and the workflow behind it. Okay, so that's Strategies in a whole. And so like that's, you know, that's kind of all the like the fun fancy graphics that we have. So now when we kind of work, right, like how Strategies works alongside of Sasaki is like we will get kind of called in for a new project, and they'll be like, we have an idea, we want to do this, and we'll kind of make something, or we'll use a tool that we've made and we'll do something on it. We'll, you know, run an analysis or whatever, and then it's done. Like we kind of just do this handoff, and maybe there's an iterative process, but this is kind of the concept, right? It's like we kind of get brought in as a bundle, and we get added in, and we just kind of, you know, help the design grow and try to inject and help produce a little bit better. Now, what that probably actually looks a little bit more and similar to what most people probably feel is like that's not a linear process, you know, like you're going in, you're exporting things, you're saving it, you're sending it somewhere else. But it's always kind of this, you know, emotional workflow that doesn't really have any relationship to how you thought it was going to go. So And that's just like when one of our team members get brought in, and we have multiple team members. We have a lot of great specialists that can do excellent work, and we're and yeah, thanks to the final two really not done.com. But I think, when you have multiple people doing all these things and kind of like you're really trying to push out something that is like something to be put along the side of a project, it's always these, like, everyone has these different types of workflows, and we try to tie it all back together, and it becomes a headache. But, let's circle back to, like, let's talk about one person, right? Like, that one part of the workflow is always kind of crazy because there's different elements, there's different ways of collaborating, and this is just from the specialist perspective. You don't really ever, like, when you tie that back into how a designer might work, it's not really this. They're kind of like, this is a lot of issue for them to take on because there's just a lot of work to kind of lean into this and help it actually expand the design process, let alone incorporate it into the time allotted for the design. So, so we kind of get brought in as an isolated node, and then we do our work and we kind of hand it back, and no one really ever wants to touch the spaghetti. Now, where we find this like awesome, like kind of like opportunity in what we've actually been deploying and finding it really beneficial to our workflow is using Speckle. And we kind of jumped on board with Speckle 1, and we're using it for a couple of projects, but then we started really jumping into a Speckle 2, and we've been really enjoying how it's like we've been able to kind of take it under our workflow and see it as something that we're able to just say, like, okay, a project, a tool, it all relates to a stream. And when we can kind of incorporate all these things, we understand how that workflow kind of comes back together, and it can produce that final dot done. So it's kind of nice. So that's our little, like, that's a kind of our little happiness that we see with Speckle. So I figured it'd be good for us to talk about our approach with Speckle itself. So oh my God, the sound's on, and it's just really, it was like a squeaky little voice. Sorry. One thing first, we have a big firm. It's like less than 300 people, but we want to get people on board with these tools. So I've done like this little presentation the last week, and really kind of getting the excitement for Speckle and talking about like how people can interface with it, how people can onboard with it, how they would actually go through and like work with us on it. And we're getting really excited because really, you can create the coolest tool, but if you can't really motivate the people that you're building the tool for, it's never going to be adopted. There's too much friction, and that's something that we kind of learned from our strategies team, is that we've been typically a prototype-based tool, like prototype-based group, but now we've moved into like more of a platform or a full-fledged tool that's packaged and kind of completed. And so, what we've realized is that having a good user experience is key for someone to adopt that into their workflow. And so, what we kind of find helpful is, like, when we look at some of the stuff that we're excited for with Speckle, is like, not only is it, okay, we got to make sure people are going to use this and get excited for it, but also we kind of see it as a beneficial for our developers. So, as we mentioned, we build a lot of tools, and this is kind of our little web page that all of our Sasakians can access, and it has, a range of different utilities, tools, services that we offer. And so I think, when we kind of look at this, we get really excited because what Speckle kind of brings to the developers is this opportunity to relate metadata. And all of our tools here that you're kind of seeing have this, like, a kind of approach of taking something that is just a geometry, an item, maybe some raw data, and always passing around metadata for it. And that's something all of our tools have in relationship to each other, and we're really excited over how that helps us build a way of like structuring it. It simplifies a lot of things that we would build customly all out as like individual pieces. So we're really pumped for that. So we're a little clip at the bottom. But so, okay, we're excited. So what are we doing? So the last couple of months, I've been kind of pushing together an app that's kind of doing like view analysis, and that gave me an opportunity to really test out the integrating like the developer features of using Speckle kits and Speckle converters, and this app that I'll show you in a second works with different clients. So realistically, we were like trying to figure out how to build this, and what we kind of found and what has been kind of inspiring from a post within Speckle community about structural classes is that we've been thinking like, well, if we're going to build out all of these items, might as well make it like a set of tools that people could use within the Speckle object like library. So we've been kind of thinking like, well, maybe just as there's structural classes, maybe there's design thinking classes, design tools classes. I don't know, names TBD. But we've been really excited, and we're pushing out some series of stuff that we can offer internally to our group, but also we want to be able to publish these things for the rest of the Speckle community to like think about, grab, and maybe use themselves. So we'll go over the first two today for view objects and scale comp, and we'll do a little like we'll do a little kind of demo on this stuff. So just to give you a little sense of how we think about things. So bang, okay, killer diagram. But so this is the first thing we're going to talk about is scale comparison. So a thing that is kind of important, and most designers have probably hit this, is like when you draw something in a floor plan, there's really this moment of saying like, how big is this thing? You can draw in some context, but really the relationship of things is really difficult to understand. And this is just looking at architectural floor plans. We haven't really, like when you go at the level of like master plan, when everything is really boxy and you're doing multiple buildings, it's hard to understand the experience you might have when you're, when something is really kind of trying to be fine-tuned from like a 15-foot alleyway to a 30-foot alleyway. Like, what is really the difference of that? And there's a lot of things in composition that we would have to understand. So we kind of built out this tool. Okay, demo. Let's see if this works. I think it will. Oh, wait, hold on. No, I got to do the whole thing. So if you haven't done those, this is for Speckle people, you'll probably laugh because it's pretty much the Vue app standing up on itself. So we built this app that helps you, that does kind of has a relationship of pulling in polylines into Google Maps. And you can kind of do it all from Speckle. So we have a Speckle stream here that I've kind of been committing to, that it just has a bunch of different 2D line weights. And then within this app, you can just kind of go and say, oh, okay, I want to compare some of these drawings I've been putting together and see how big they are. And we are in beautiful London right now. And let's see. Okay, you guys are probably going to laugh at me because I really don't know London. So I'm going to try to find a cool place. I don't know, this harsh line. It must be raining there. Okay, so basically, right. So we have Google Maps here, and then we also have this, a series of streaming commits. So if we wanted to say, let's reference an object and place it in this map, we want to get a sense of what that experience of scale is. So by simply just allowing you to actually place that object in here, you can now just kind of go in and see, like, you can see that 2D line work placed in here, and you can move it around and understand the scale of it. So this is actually this is a single building site plan that I have in here. So it is kind of small, but let's say, to kind of continue this idea of design thinking, let's say, our kind of dream idea would be like, okay, let's say we have some people in here, like people are kind of doing a screen share and trying to understand how this tool, like how this space is working and how it can kind of relate to things. Well, a lot of times designers really use Google Maps as actually a great place to explore and understand like different contexts and sites. So part of this tool is that you can actually kind of come in here and do a drawing where you can say, okay, I really, like maybe before we'll like put my little guy down here and start to explore and be like, wow, this scaffolding, just mind blowing. I want this in my project because no, I won't do that to you guys. Sorry. My sarcasm is just through the roof nowadays. Hold on, let me scoot out here. Okay, beautiful street. Okay, cool. Let's say we really like this section and street. This is an urban design function that we want to use, but we want to know the proportions behind it. Well, we can swing out and say, okay, well, that was Chapel Street. So let's just kind of measure this out and just take some dimensions on it so we can understand why we like that experience and have that relate. So we can simply just draw a little polyline in here, and that lets us kind of have an area, and you can actually go and say like, let's click there. You can see what the size of it is, or like what the area is if you were using area tool like this. But it allows you to start to kind of have a platform to like draw and animate, or draw and just annotate different things over a Google Maps like diagram. So while you're in here, you can kind of imagine that you're doing all this work. And what we were thinking too, this isn't really built in yet, but one of our features we're thinking is like, well, it'd be great if if we're taking this tool, we don't want people to just do a screen capture and walk away and be totally fine with it. We want it to be something where people are like, oh, like this is this drawing here, I want to be able to reference this later. So maybe when you do this type of drawing, what we would like to do from here is be able to actually send this back into a stream and say, like, maybe this was a design review, and all of the polylines that you have in here are now saved with like metadata that relates to the Google Maps API. So, I think that's something that we haven't really explored too much yet around how do you send data back from the web into a stream. But really, the goal behind that would be to help us actually annotate the the data that we're drawing and sketching in real time, and have that actually be something we're relating to within our stream. So it's not like copy paste with just screenshots. So yeah, so that's kind of a little bit of a glimpse of the scale comp tool. And this is a 2D viewer of itself. And we have also explored like using this in AR and stuff like that. But realistically, what it really helps us is being able to use this type of scale comparison really like right from CAD, right from Rhino, just sending in a polyline that allows you to kind of place that in an area and understand the relationship of things. So, experiential analysis is something that we're really kind of leaning into, because when you can put numbers all day up and show like what the values of certain things are, but people really understand things by experience and by being immersed into it. So that's where I think that's kind of a key thing around why we find even just the idea of scale comparison in Google Maps so relatable and so easy for us to see the value in as an application. Okay, thank you very much for working scale comp tool. Okay, now let's jump down back to here. Okay, demo please work. That worked. Super happy about that. All right, drink water. Kitty, you're just hanging out in the corner now. All right. All right, so the second tool we're going to talk about at the moment, and this has kind of like been my baby for a while, is ViewTo. And so ViewTo is a view analysis kind of tool, program, engine. I don't know. It's a tool that's built around doing GPU-based view analysis. So what we end up doing is that, like in a very simplistic way, we create a bunch of points that allow a camera to move and take a screenshot there, and then we use that screenshot to then calculate all the pixels, and that gives us a series of results, right? So that tells us, let's say we wanted to be able to view how much water we could see of a space. Well, we can do that by understanding what that geometry of water actually looks like, and then using that to capture and know how much of that water might be seen. So that's like kind of a very basic way of looking at this. And view analysis is something that's been done for a while. Like people have been using it to do line of sight. You can also use the feature in Google Earth where it allows you to kind of see the distance of like how far out you can actually see at what height. And so this isn't like view analysis isn't like the freshest new idea, but the way that we're kind of approaching it is a key thing for us to kind of have like a difference in how everything is working. So, right, like kind of as we were talking about it, we said that you kind of have to break things down and under a way to understand how all of the data actually compiles, right? So let's say you have a view, right? Like realistically, we're kind of judging the value of each point by how someone actually sees out of that point. So let's say this is a point here, and you want to know how much of this site here in blue you have, and how much of those pixels you can see. And then you also want to add in some of the things that you're designing with. Maybe some of these trees are your design features, and so you want to make sure that you're not blocking it too much, but you're, like that you're kind of maybe framing it in a way. So we kind of, take that concept of targets and blockers, and we kind of break it down into a way of structuring how the pixels come back. And so when the tool runs, it basically goes through every single little frame and every single frame at every point and takes a photo and counts every single pixel. And if it looks and finds if it looks and finds the color it's trying to look for in the target, it will count it and then store it. So you kind of see that it's just like a GPU calculation, right? But what's also really helpful with this is that since we're doing it on the GPU, we're doing it with the processing power of the GPU. And that's what's really nice about using this tool within Unity is like you're not only using shaders, you're using compute shaders. You're allowing a lot of data to kind of come in and out at a rapid speed, and we're able to kind of process like thousands of points within 10 to 20 seconds or something like that. And we're getting it's really nice to kind of see a tool that has a simple concept but also is performing very fast and giving us iterative design thinking to kind of analysis. So this tool actually first started as a web application, and so we would actually run the tool's data in Unity, but then we would just go on the web and allow you to kind of click and move around and be able to see the views in here. And we ended up like, what was kind of cool about this tool was like, being able click around and see all the different views in here and having it on the web and seeing the analysis kind of compared to each other. And we, like the web tool did a really great job of just like giving us an interface to work with it. But then we kind of actually hit this point where even though we were doing this type of analysis, it wasn't actually like we could do that analysis, but we weren't actually passing it back in like a thoughtful way to the designers. We were doing this work and they would just kind of we would have to relay the different experience that they like of the values there. Like they weren't absorbing it correct, like all the way through. And they weren't also like able to iterate with it because it was detached. So we kind of realized like, okay, if we want to remake this tool, we have to make sure that you can set everything up within a native platform that someone would use. So like Rhino, for instance, like we use Rhino a lot. I really like Rhino, so I'm just going to say Rhino, maybe, or Revit, I don't know, whatever, SketchUp if that's you. But Rhino in general would be like a great place to set this tool up, and you would kind of set up this idea of like everything that you need to do to make an analysis, and then you would pass it into, I guess my Unity logo is gone, but this is Unity, and you would pass this into Unity, which then does all the processing and then send that data back into your native application. And the reason to do that is so you actually are creating a way for someone that is going to be modeling, designing, iterating, and thinking to be able to view and process that analysis and experience it not only in like a visual way, but also in a way that ties back to the work they're designing and doing. So a big goal for us right from the start was, okay, if we do this analysis, it has to come back and full circle all the way back into right back into whatever program you use. So here's a couple of examples of some of the analysis we've done where people were looking at like some of the grass here and the relationship of how the buildings were blocking it and pathways. And then here is another example where this campus in Denver, Colorado, I think it's Denver. No, Boulder. Okay, Colorado. There we go. In Colorado, where they wanted to see these three different campuses here and their relationship to the mountain range that they had in the back. So they wanted to know where's the best views of the mountains from these spaces, and where can they know the best way of like actually having where's the best places to maybe have like entry points for their campus. And then we also did an analysis with the roadways. So using the top of the roofs for all the proposed designs, they actually wanted to see how people would, when they started approaching the from the highways, what did it actually look like when they saw the campus, and they how close were they? Where's like kind of the key points where they might see all of the different roofs from the road. And so it's kind of that thing, like when you're driving in a car, you can kind of understand like where you're going because you're getting visual cues. And so that's kind of like how this tool's kind of started and has been utilized so far. So I wanted to take a second to actually dive a little bit more into the view components of this, because this is actually kind of relating back to the design tools, thinking, object, kit, class, whatever. This would be some of the stuff that we would like that have already kind of built with the Speckle base component or Speckle base class. And this would be some of the stuff that we kind of make open source. So, really how the view analysis works is you kind of break things down into a study, and a study has points, targets, and blockers. So, a target is really the thing you're trying to look at. The blockers are going to be the things that block the target and make it so you have an impacted view. And then you have a series of points that come in. And so the points really can be any sort of format. You might have something in a building, you might have something as a cloud because you're doing massing or something like that. But it all kind of boils down to however you want that analysis to work for you. So, we kind of release these as like view clouds, view content, and view studies. And so it's not really like open source, but it's totally available if someone actually wanted to grab it and run with it. Terrain is actually a geometry, or just the terrain is actually a geometry. So that's like all of the stuff in here. This is kind of what you would see in your model. So we have a couple of tools that actually allow us to do some like quantified meshes that allow us to kind of build in a nice 5 kilometers is vector by curvature of the Earth. Oh, right. I'm going to note that because that's good to know. Well, luckily, I don't know how far out the view actually goes, but that's a good thing to point in there. So for easily distracted, as most people can see, that's who I am. What we're kind of doing here is going through and showing some of these points. And then when you kind of look at it in Unity, what ends up happening is like what we haven't talked about yet is the Speckle component. And this was actually first built on Speckle 1, where you would stream in the geometry and the points. And actually, it was just the geometry at the time. I was writing the points as like CSV and stuff like that. And you would run a series of cameras through it. So you could have a camera that has a cube, or is just horizontal, or maybe focuses on every single point, or has like normals that direct it. And you can kind of see as like you would put together this rig, and it moves through and goes through this process, and it kind of goes through a series of stages of analysis that kind of helps you understand everything as a full study. When we first started writing this tool, and this was before Speckle 2, is I got my first glimpse of I'm not a programmer. I've been trying to learn programming for the last couple of years, and I feel like I've grasped it a little bit, but I felt like a big learning curve come in when I had to write a file management tool. And it took me a while, and it was just understanding how to structure a project and tie that project into a study, and how do you keep track of all the IDs and load those right CSVs and all this stuff. And then all of a sudden Speckle 2 comes in, and it's like, oh, I can just throw all of that away, and that whole couple of months I was just working on that doesn't matter. Thanks, guys. But so what we kind of jumped in once we started going into Speckle 2 is like we actually saw, and this is kind of just a random tangent, but right when we made the transition of going from Speckle 1 to Speckle 2, we actually ended up utilizing the base object classes. So I'm not sure if you can really see it, but you probably can't at all. But some of these classes in here, these are all just the base Speckle object that we use for prototyping. And what was really nice with that is that you could actually lay out all of these tools as a prototype and understand the data structure of all these things and how they relate to each other. And so when I made that first jump of moving into Speckle 2, I already had a understanding of what the data was going to look like when I passed it into Speckle, because I was using these simple tools in Grasshopper that I would usually want to rely on for actually building and structuring this data. So it was nice to actually see and discover that oh wow, this is super cool. And it goes all the way from setting up your view clouds, which are just your points, to the how do you want your camera set up, to what type of targets you want, what's your blockers, and how's the study being built. All right. Okay. Demo 2.0. Fingers crossed. All right. So uh-oh, come on, Unity. Come on over, bud. All right, so in Unity, along with my brother, but not brother, Jed, and Mateo, we've been kind of working on the Speckle connector, and one of the things that I've been trying to just leveraging that. So I figured I'll do a quick example of how this tool actually works. So right now there's a object within the Speckle connector that is just like kind of a manager, or sorry, within the Unity scene, which acts as just has a component for the Speckle manager connector. I don't know, whatever, you can call it whatever. And then I also have this object here for a ViewTo controller. So this is kind of like the main controller. It's a little gross at the moment because there's just a bunch of fields and parameters that probably should just be isolated, but it's a demo, so whatever. Okay, so let's say you have a study that you want to run, and what ends up happening here is like you end up setting up whether you want to run it on load. Okay, you know what? We don't need to show that. Whatever. So pretty much in Speckle, like in Unity, it's the same way that most of you probably know how to use Speckle. So really, you're just selecting a stream, a branch, and also a commit that you want to use. So and here we're just saying, okay, I've already pre-picked one, and I'm also using a kit that I've imported right into Unity. So kind of that's another annoying thing because Unity deals with things a little bit differently than most C# programs. So like, I don't know, you have to kind of like make your own kit within the repo. So, okay, so we have it here. We're great. The suspense is building, and then we hit receive. Oh no, did it? Okay, wait, okay, it didn't receive. Okay, so I actually just tested this out right before this. So I think this might take a minute, or at least I was ready to tell a story, so that's cool. Maybe it just worked in a cache. Okay, so so pretty much what you're seeing here is it's not really actually breaking down the geometry. So, oh, okay, it's just the mapping thing. Okay, so what you're seeing here in the editor is that this little rig that you kind of have all these different views for, going around to all these different points and like pew, 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 capturing the views and reporting it back. And then that's actually allowing us to have a set of data that allows us to, see what the value of a pixel is. And this kind of comes back to the idea of experiential like analysis or thought or whatever. Is like, we would do a pixel value, whether it's like, saying like, okay, we have 54 pixels now. And like that, and when we map it, we're saying, oh, this is really great because we have 54 pixels. So like, we were thinking in our heads when you do like max versus min, we were seeing like, okay, that should be, when we map it on a gradient, that will be a green. And we're really happy because that's the highest value we can get. But when we were actually relating that back to the design teams, and so as that's kind of working on, we'll kind of jump back to here for a second. Well, you know what, this is like a loading screen. We'll leave it here. So, like when we were relating this back to design teams, what we kind of found was that they were not understanding what it meant to actually have to have that quantity of pixels. Like they were saying like, what's it actually mean to see, like, what's that view actually feel like? And, this is some of the stuff that we're like, kind of tripped us up, and we're like, well, what is the value of a view? And, we started realizing like, okay, well, what ties into actually validating a view? Was it just like how much of something you can see? Or is it like understanding the proportions of something? Is it being able to have the clearest view? Like, is it being blocked? Is it, like we've kind of like, we're going through this process of like understanding all these different types of structures for for explaining the experience of it. But also like a thing that we're kind of keen to looking into for figuring out why and how this would work is kind of tying this into an explorer that is based in VR. So someone could go in and actually go see this view, see all the views in a VR headset, and be able to look around and experience that view and understand the validation of it. So, and you could kind of tie that back to a way of someone saying like, is this a good or bad view? And if they say it's a good view, we can start to, kind of understand what they are saying is a good view and kind of relate that back to the pixel count. And, I think, oh God, I'm having a little bit of a brain fart. And also, something that might actually kind of take us into a different route with understanding this is like the location of something. And you know, we've talked a lot about the developer features for Speckle, but some of the other stuff that we've been really excited for is like, how does Speckle also go into our workflow for automation? So you know, when we consider the idea of like how do you actually take different sorry, oh my god, this is what happens when I get distracted. So like, you know, if you take in the idea of location, and one of the things that, like, I remember when when Izzy released globals as a feature for Speckle streams, I was really excited, but I was like, I have no idea how I'm going to use this. And finally, we kind of came up with an idea for how Speckle would like how we could utilize globals. And one of the features we're thinking about is, well, maybe we need to locate like we can set up the location of of your stream and have that global parameter help relate back to the value of maybe the real estate in that area, or, you know, any sort of other like kind of physical elements that might impact how someone's view is valued in that area. So, you know, like that, like sometimes we have to work with developers and clients that are trying to get the best view of an ocean, and they want to be able to know that the top floors have the best view. And, you know, it's kind of like that typical crap that like you just kind of go through, and we're trying to understand and validate that. But that was one of the things that we're kind of realizing now is, like, with Speckle, not only do we have the idea of object-based metadata, but we also have project-based metadata. And that's something that's really exciting for us, because a lot of times when we start a new project, we'll go up to project like I don't know, we'll go up to like a project for 2 weeks for a competition, and we have to set up all these different streams, but we do all these different types of analysis, and or like we'll set, like, you know, the coordinates up with AutoCAD Civil 3D and blah blah blah. And so I think when we see what Speckle is like, well, we can do these different types of streams that kind of accompany what type of data people need to set up a project right from the start. And it helps us with our workflow and gives people an opportunity to have that data set up, structured, and ready to run right from the start. Okay, so this has been thrilling. I know you guys are just like, wow, my mind's blown. So I'm going to skip this and just go right to an example. So, you know, just to kind of like showcase what this ends up looking like. I was actually trying to pull this into Grasshopper, but something wasn't going all the way through. You know, you would basically get a, you know, so my headset just turned off. Okay, cool. It shows that I'm still talking. That's hilarious. Okay, so you know what this is? Woo! Thank you, David. David Power. You know, basically when you do an analysis, the one that was just running there, is it comes back and is actually like kind of taking each point and painting a value to it. So you know, this here is trying to understand like the impact of a design option from the like landscape team, and how does the landscape actually impact some of the views on the building. So you know, I think we're still kind of pushing through some of the validation for these points, but you get a sense of how the tool's working. And what's nice is that when we actually push this back into Speckle, you know, because this is all wrapped in a, you know, because these are all Speckle objects, now when we open up a stream, we can actually, let me try to find one with an actual colors pointed on it. Yeah, there we go. We can actually get the results back with it as a cloud. And so this is just utilizing Speckle's point cloud object, and we just take the values that we have from the result and just kind of paint them on here. And you can kind of see that these aren't right, but you know, it's nice that we have this relationship of saying, okay, well, we did an analysis, and we have that analysis actually not only available in Grasshopper and here, but on the web. And you know, when you have multiple different teams and multiple different clients kind of contributing to things, we need to figure out ways for people to review and explore the data, and it doesn't have to be just in a modeling program. So right now, this is kind of the handy thing of building out this kind of design tools, thinking whatever TBD kit, and having all that data kind of pass around in here. So you know, we still have a lot of plans for how this works, and we're still kind of fleshing it all out. So all right, let's wrap this bad paparoo up. And that's it. Okay. So that is the conclusion of this amazing presentation. Hopefully it was amazing. But and we kind of have some other ideas in the pipeline that's coming down. We're still looking at a lot of the tools that we've built out with we have like an SVG floor plan scraper and like something for like setting up programming stuff. And we also have like a really good set of spatial analysis, spatial analysts and geospatial analysts, team members on our team that are looking into how they want to utilize Speckle from GIS or from from Excel and incorporate that into our design workflow. So that is kind of everything there. I'm done, and it's a little early, so I guess I can take some questions if there's questions, or if anyone just has like a general statement, I'll react to it. You're welcome. All right. Oh, so Mark, okay. This seems to cross over to GIS quite a bit. Appreciate it. It's not Speckle, but we have looked into QGIS for creating the points and stuff, but a lot of the times that we have to work with doing like point creation, it kind of all starts with like modeling. It has to be three-dimensional and model based. So that's why we tend to rely on Rhino or Revit or whatever, and that helps us kind of set up the points and structure everything and then deploy that. So we are looking into how we can do geometry relationship and like point creation in QGIS, but I think right now we've just realized like it's much easier to leverage all this work from Rhino and just kind of pull in like the quantified meshes in Rhino itself. Thanks, Anders. Rhino, okay. Well, cheers. This is a bit awkward for me, so I'm just gonna, maybe I can tell you a story. I don't know. Maybe I should have not flown through that. Maybe, I don't know. So Jed, what do I do now? Jed, my brother.
Hey, how's it going?
Hey, man.
I think excellent demo, by the way.
Thanks.
Those demos for showing Speckle, really great.
Yeah. Glad it worked.
I think there's a few questions in the Q&A section.
Oh, okay. Oh, there's a Q&A.
There's a
Okay.
Q&A section.
Oh, my bad. Oh, I don't have any questions here.
There's one from Shane.
Oh, how do I see the Q&A?
So to the right, you've got the chat, you've got polls, and you've got Q&A.
Okay. I'm looking at that now.
No, sorry. I'm looking at the wrong one. There's no Q&A. I do apologize.
Jeez. Okay. Well, for that you have to say a question. No, I'm joking. Yeah. Well, yeah. No, that's great. I can answer Shane's question if you want. I don't know what it is. Let's see. Start just taking random questions. Was that? Oh, maybe that is from Shane. Shane, are you in here? Shane,
there's a question from Shane 3 minutes ago in the event Q&A, which is who is the target audience for these tools. But I'm not sure if he's in a different session, but I think it's a valid question.
Yeah. I'll take it. I'll run with it. So the target audience for some of these tools, yeah, I would say it's more for the designers. Right now, it's being built for specialists to use because it's just like right now it needs the specialist to adopt. But some of the reasons we felt that the strategies work needs to kind of embody a little bit more like a better UX around this is because we find that like if you only design things for a specialist, you're only designing like one thing that can be used by a team, and only one person will use it. And so we tend to find that like we tend to find that we need to kind of design things for everyone. So but that's a challenge in itself to make proper UX and UI, and like not like our firm is fortunate enough to have that type of backing that allows us to actually deploy that type of work. So oh, his question disappeared. But thanks, Shane. Oh, okay. Questions in the chat. Got it. Okay, cool. Oh, all right. Thank you. Wow, great. Okay, so yeah, so I mean, our target audience is right now first attending to specialists because that's just who really adopts the tool first. But then our goal is to the design team. So we are working on, like that's why we have things that tie right back into Rhino, tie into the web. It's anyone on the project team that could be able to work on these types of tools and be able to utilize it. So that's kind of why we have like a multi-target right now, but we go in stages. Like it's hard to target the design teams when a lot of that work behind getting design teams to take on a project or take on a tool is going to be around UX and UI, and you need to like build out the actual functionality and the core logic behind it. Which tools are available to the public? The scale comp tool is, I think, available to the public. That is just, I'll post that in here. I mean, it's a sketch, so yeah, just take it at scale level. Using that Netlify example from Speckle. But so ViewTo currently is not like the runtime application is not open source, mainly because that's just what we're trying to control is like our investment into like a spatial analysis, and that is something we're kind of building out as an engine for our like kind of computing a lot of this analysis. So we're trying to make sure that as much as we would love to share everything, we do need to like, know what we can kind of control for ourselves. So I think at one point we might have a version of ViewTo open as as an application you can use. But for now, I think we're just still, since it's a work in progress, we're just kind of keeping it within our private Bitbucket. Sorry, that was so sad. I feel like I'm so sad. Okay, wait, I saw another Q in the A. What developers do I look most up to? Oh man, I think right now I've been really looking at. I mean, I follow David Rutten a lot, but I honestly like my background in programming is very like like I said, like I've just been kind of jumping into programming from architecture, and as much as I like am happy with the work I've done, it's definitely takes a lot to get here. But I have to say, like I've been really enjoying working along Speckle. Like I comb through their repos all the time. I learn a lot from how they structure things, and they're always happy, the whole group at stand up. So I have to, and maybe that's just a secret. Maybe you guys are all evil people behind in your private Discord that you guys won't invite me to. But I do think there's like, I really enjoy working with them. I also think like Zach Lieberman and some of the visual creative coders like Max Cooper is really cool. But I definitely wouldn't look for look for me for developer advice. I'm more or less a Stack Overflow groupie. But I do like 3JS. I do like seeing the examples on there, and but I mainly stick in Unity and Rhino. So my world is .NET. Cool. Let's see. I'll swing back to the chat thing. Okay. So let's see. Hold on. What time is it? Okay, we got 5 minutes. I'm hanging. I'm here. What do you guys got? I'm from Vermont. I speak a little bit of Spanish now. Muy poquito, mío. My wife just got said. My Spanish classes are great. I have a Spanish class today. That's my cat that you saw. Her name's Kitty. She's 13. Jose. Or no, wait. She's 12. She's gonna be 13 soon. Nice, from Colombia. Nice. Never been, but that would be I think we would love to make the trip there. What other little random tidbits of knowledge can I share in 5 minutes? Maybe I should look to make sure I didn't forget anything in the slides. Yeah. Maybe we'll just put a nice visual in there so things are satisfying to look at. Yeah. Well, I think this is a good point to say, if you're still here, I appreciate it. There's my cat. Her name's Kitty. Again. Oh man. Yeah. Okay.
I have a question, David,
Yeah.
about the previous Unity demo with the view optimization.
Yeah. What's up?
Is how are you selecting the view positions in Unity? Is it just even spacing, and then you're looking at the cardinal views, or are you using some sort of algorithm to choose?
Like, so we just all the points. So you're saying like, how does the camera move there?
Yeah.
So those are points that are just created in Rhino beforehand. So you would actually model, like you just kind of like might do it. We have like a contour script that allows you to just generate those points, but our kind of a lot of the fancy work happens in the shader. So in the compute shader itself, it's like going through and taking each pixel and does some math to figure out like how close it is in a radius, and then gives that a value and sends that back to CPU. So. But yeah, it's just generated in Rhino.
Oh, excellent. Thank you.
Yeah. Cool. Well, I'm gonna, you know what? I think if you guys haven't gotten an extra coffee, maybe get a water or stare out a window, I'll call my presentation there. I'll hang out for another couple minutes, but I really appreciate you guys jumping in and saying hello and listen to me just ramble on for a little bit. You can also, I guess to plug our stuff. I mean, you can. I guess yeah. You can. Oh, I'll put my. You know what? Yeah, contact information. Here we go. Bang. Present. There we go. So if you do want to reach out to me to talk about any of this stuff, that handle is for like my Instagram, but also GitHub and all that other crap. And you can reach out to me on my email there too. But I'd be happy to talk about Speckle, VR, AR, my cat. I won't bring my cat up anymore, I promise. But yeah, and you can, like, get in touch with us. We have a great team of people too that would love to, we have, I don't know, everyone's really kind of cool. So, okay. I wish there was like a curtain. I guess you could. Thanks, Alex. Yo, Tristan Morgan. All right, Jed, we have another brother or sister. Not sure, like this Morgan crew assemble. Yeah, thank you all.
Excellent. Thank you very much, David. That was an excellent presentation.
Awesome. Thank you all very much, and see you around Speckle stuff.